Well, good afternoon, Form 4 boys and girls. So the target of this clip is to supplement what Mr. Kai said today in the online lesson. So I would like to give you more, and some of the things I think that you have to consolidate well, before you learn more about this chapter. So this is the reason why I take this clip to give to you. So before we really learn the new things in this chapter, so I would like you to go back to see the content of this chapter. The content of this chapter, chapter 10, basic properties of circles. So you actually understand that what we have to learn is about circle. But do remember is that the idea we have to get is a geometry about the circles. That means that you will face many geometric figures, including what you have learned in junior form, including lines, triangles, quadrilaterals, or even something like angles, parallel, something like that. So do remember is that because we are talking about the geometry, the geometry about the figures. So you should prepare that there will be something like proofs, reasons that you may need to use for this chapter. So you have to remember is that you may have to do proofs or you have to write reasons, just like what you learned, for example, in contriangle, something like SSS, AS. Those reasons will be appeared again in this chapter. So now, before we really start learning the new things in this chapter, so we have to take some review that what we have learned before. For example, the things like Form 1 you learned, parallel lines, just like the reason like corresponding angles, alternate angles will be used, in this chapter. Besides of parallel reasons, so there will be a very important thing that I think that you have to highlight in the book. So I put 10 stars here because I think this one really worth 10 stars. It is about isosceles triangles, ISOSCLES triangle. So please remember, in this session we are talking about a circle, but actually the geometry of circle are really based from isosceles triangle. That means that all the reasons would be similar or really the same, exactly the same, comparing with the circle reason for the isosceles triangle. So do remember some reasons we actually always remind you in Form 2, just like base angles, isosceles triangle, and sizes opposite equal angles. And one more is called the property of isosceles triangles that you may always use, in this chapter. Besides of isosceles triangle, there will be also some other triangle reasons like conical triangle and similar triangles. So I think that you can master well, although we use always in this chapter also. Now, besides of triangles, we will also have diagram. So I think this one is very easy. So you can see that those you need to review would be actually the things you learned in Form 1 and 2 and also Form 3 about the detailed geometry. That means that you have to write proof and reason. So once again, keep in mind. And now we go to learn really what we have to learn in this chapter new. This is called the circle. So keep in mind that when we talk about the geometry of circle, so you have to keep in mind the idea is that actually circle is talking about a round figure with a point in the middle, exact middle, and we will call that middle is called the center, just like what I've written in the PowerPoint here. So we call the center. So after you have written this, you have drawn the center, then on the circle line, the circular curve, then you can take any points. For example, now I take the red one and the blue ones you can see on the circle. Then when you draw a line segment between the point you have drawn on the circle line towards the center, then we should have the same distance. So we will call that distance the radius. It means that when we talk about the circle, the most important thing is that you have to keep in mind center and radius are two important things that you have to keep in mind. Once you have found the center and the radius of the circle, then you can actually define the circle. That means that you will know where is the circle, how large is the circle, and all the properties are about that circle. And also you have to remember is that we will call the line representing a circle is called the circumference, 圆周. That means that the round lines around the circle we will call circumference. So you can also see those names in the next page of your book, which is the center, radius, and circumference. And do remember is that sometimes we have to use diameter also. That means that if you double the radius, then you can see the line, from one point to one point passing through the center, we will call diameter. Besides of these things that you may have learned in Form 1 before, you will also have to learn few more things. The first one is called chords. In Chinese, chord. Okay, so what's the meaning of yin? Yin is the line, okay, is the line between any 2 points on the circumference. But do remember the line segment. That means that if I say AB, so we just say the line inside AB. So we call the line segment AB actually. So we call this one is chord. Do remember is that when we learn chord, besides of the reasons that you learn in the next session, you need to keep in the very important idea is that when we talk about the chord, we can draw many chords. Just like you can see the picture I've drawn, the red and the green are called the chords. But you can compare how long are the chords by simply using some properties or simply you measure by using different names. But do remember is that they may have different size. For example, the green one is longer than the red one. But actually for any circle, that should be the longest one. And the longest chord is actually one of the diameters of the circle. What does it mean? That means that if I say the chord is longest, so the chord should pass through the center. Because you understand if it is not passing through the center, it should be shorter. Okay, so we will call the longest chord should be the diameter, one of the diameter of the circle. Okay, so keep in mind of this one. Besides of chord, you can also see that 10.1 brings you many names concerning about circle also. For example, arcs. And also you can see something like sector and segments. But I will talk this one later because these two things, okay, most probably will be used in 10.3, not in 10.2. So don't worry. Okay. Besides of arcs, sector, and segment, also, okay, we have to know some of the names. Okay, some of the special names that concern about circle. For example, you have to know what's an equal circle. Equal circle means they may have different position of center, but they should have the same length of the radius. It means that they have same size comparatively. So we will call them equal, actually equal in sizes. Besides of equal circles, we will also have concentric circles. Concentric circle means the circle share a same center. So we will call in Chinese called 同心圆, means the same center circles. So we call 同心圆. So this one will be used, okay, we will use sometimes, okay, in some of the questions. But please put in mind about the 3 and 4 because these two things, okay, 3 and 4 are quite important for us to learn advanced geometry. For example, the first one is called the circumscribed circle, or simply we call circumcircle. In Chinese called 外接圓. It means that a circle that contains all the vertices of a given polygon. For example, you can see that in this picture there are a triangle and a quadrilateral. So you can see these two circles all passes through all the vertices of the polygon. So we will call circumcircle. It means that you can see the red one, the red circle just only passes through 2 points of the triangle. It's not called a circumcircle. But the blue one, you can see pass through all the points, all the vertices of the circle, of the triangle, so we call it the circumcircle. Besides of circumcircle, we will also have something is called the inscribed circle, or simply sometimes we say incircle, INCIRCLE, incircle. In Chinese it's called 來接圓. So 來接圓, incircle is a little bit different. Is that now this time the circle is not going round, okay, to the figure, but actually we say the circle will hide inside the polygon. Just like you can see the left hand, the part A figure, you can see the circle is actually inside the triangle, while the second one is inside the quadrilateral. But the most important thing is that we will say the sizes of the triangle should touch. So you can see the word I say touch, T-O-U-C-H, touch the circle. So if you still remember, we have learned the word touch in the first term when we talk about quadratic functions. Touch just means that the straight line intersect with the curve with only one point, so we call touch. So you can see that now the point I've highlighted, for example, this one, just means that it touches one point for each of the sides. So we call the circle which have this property is called the inscribed circle, or simply we say incircle. So this one we will discuss later, but this one also a little bit important to you, so please keep in mind. Now we have to learn the second one, which talk about the chords of a circle. So when we talk about the chords of the circle, okay, when we talk about the chords of circle, so you have to keep in mind that chords is talking about what? So if you still remember, just I said, okay, before we will say that when we talk about chord, It means that we first of all to consider a circle. And on this circle, okay, then we can take any 2 points. For example, this time I take this point, I say A, okay, and then I have another one, this one is called B, okay, on the circumference of the circle. Besides the point A and B, we have to also notice that we may mark the center of the circle, because the center of the circle is quite useful for us to learn the geometric properties about the circle. So we will say that in this chapter, usually we will use O as the center of the circle. So you may keep in mind of this one, okay? That means that in this chapter, for doing any problem, you can see the book will first say O is the center of each circle in the figure. Okay, but the most important thing is that how about when we talk about the chords of the circle? Actually, if we have drawn this 3 point and the chord, then you can see something. Why? Because now we know that O is center and A and B are 2 points on the circle. It means that now if we have joined the O to A and O to B with the chord also, you will form a triangle. And also you have to keep in mind the most important idea is that because this triangle, okay, is formed by 2 radii, the radius, okay, and also the chord. So you should understand a very important point is that the radius should give you equal lengths. That means that here we should always have OA equals to OB. That means that when we compare from O, the center, towards, okay, the point of the circle, so they should be the same because we always say that they are the radii of the circle. So it is also one of the reasons that you see most in this chapter if I want to explain why the lengths are the same, because they are radii, okay? So because the radii comes, that means that you will see that with considering the chord together, it will have an isosceles triangle because you have 3 sizes, 2 radius, and also the chord, so you form the triangle, and this triangle should be isosceles because you have the radius here. That means that all the property of isosceles triangle also works inside this circle, including what? So if you still remember that in Form 2, you have learned many reasons about isosceles triangle, just like what? So I think that I have to make it bigger to let you see. For example, you can see in this circle, the most important thing is that now I can draw what? You can draw a line from the center again towards the chords. But we don't know actually where should be the line goes within AB. That means that you can draw the line like this, or you don't need to draw the line so vertical. For example, some of you may say, Mr. Wong, if I draw slightly near A or slightly near B, just like this one. So what we have. So actually, if you still remember what you have learned in Form 2, you will not have many things about this one. Okay, you may not have many things about this one if you do not draw very strict. But if you still remember, there should be a property is that if I really draw it vertical straight enough, that means that if I have drawn the line like this with also the right angle, then I should have a very important result is that after you have joined this one, for example, now very sorry here, oh, is a little bit lag in my computer here. For example, here you can see if I join and you have this one is the right angle, so I think that I should draw it better to let you see. For example, like this. Okay, for example, now I have drawn the line like this one. Okay, for example, now I mark this one as the right angle. Then we have a very important result is that by the property of isosceles triangle, if I have the right angle in the middle, then we should have these 2 lines with the section equal. If I say this point is called M, and this one surely is the property of isosceles triangle. That means that actually the property, okay, of isosceles triangle comes here, and also it brings us to learn inside the circle also. For example, now you can see the first reason produced from the book. For example, you can see the word say if AM equals, so here it should be the reason here. If OM perpendicular to AB, then we will have AM equals to MB. And you can see also the very long sentence reason, perpendicular from center to chord, bisect chord. But don't worry is that in DSC, that means that practically you don't need to write so long words here. That means that don't worry is that this one, okay, you don't need to spell, okay. Even I ask you to write reason, you don't need to spell too long. But what you need to write, I will teach you later. But do remember is that you don't need to spell too long. And also you have to understand is that why we have such a property. It is because a very important thing is that now you can see that inside the circle we have shown the center and the 2 points on the circle, just like A and B here. But actually you understand is that if I join the OA and OB, it's just like what we are doing before, the isosceles triangle. So because there is an isosceles triangle inside the circle with the radius not shown, but it's still the isosceles triangle, then means that you have all the property of isosceles triangle. Just like right angle implies equal lengths, or this should be only one stroke here. For example here, So for example now you can see that we should have one. You have right angle, so you have the equal parts of the line in the bottom. Similarly, you have the reverse, or you have the converse in math formally. That means that formally we should say this one is the converse. In the converse, we will say that this time you have the equal length, so you have the right angle. So actually, you have to understand is that the theorem 1 and theorem 2 are just comes from the property of isosceles triangle. So you don't need to spell so long words here. Okay? And besides of theorem 2, so I would like you to take a look on theorem 3 also. Theorem 3 is talking about what? This time we don't know whether the two lines, including the chord and the line we have drawn, is passing through the center or not. But we say, if I have a line CM, just like you can see in the left hand side figure, which makes right angle and equal parts of the chord. So actually, if you still remember that, we will call this one, this CM, and this line, if you still remember that, we have a very important name for this one, which is called perpendicular bisector. Oh, sorry, there should be an R. I missed to spell. So this one I should have perpendicular bisector. That means that if I know that now we have the line which makes equal parts and also right angle, or simply we say perpendicular bisector of AB, then we will say that this perpendicular bisector should also pass through the center. That means that if I make the CM longer and longer, finally it should go through the center of the circle. So it's very natural also. Why? Because you understand that originally the isosceles triangle we are talking about, which is OAB, should have the isosymmetry in the middle from O towards the midpoint of AB. So if I have known that this midpoint and also right angle, so you should know that the line should also be the isosymmetry of the isosceles triangle. It means that actually when we talk about the chord, the first three theorem that you learned from Mr. Kyle from the book, you actually get the idea is that why do we have such a result is because isosceles triangle. So once again, here I would like to write on the screen to remind you that what we are doing is just only isosceles triangle, and we bring to the circle. So it's just like you are doing the circle version, the circle version, isosceles triangle. But actually the basic idea is always from isosceles triangle. So you can see what we may have to do in the questions. For example, you can say example 1, say now you have a circle and then I give you OC is 10 cm, ON is unknown, but you have a right angle here, and then you have CD is 16 cm. So now you have to find ON. So even in this question you don't write any reason or write any words. If you first take a glance, that means that you first take a view on this one, you can surely to know that we can make a triangle OCD by writing the OD is also 10 cm, because you know that they are radii. They are radii radius, from O to C and also from O to D. So we will have these two lengths equal. Besides this, because this is an isosceles triangle with right angle, then I can also understand that the CN and DN should be in equal lengths. That means that you have this one is 8, this one is also 8 cm here. So why we can write quickly that OND is x cm, or we say CN is x cm from the given figure? It is because we just use the property of isosceles triangle, then we can get the result. And you may ask, oh, Mr. Wong, if I really write the answer by writing the steps, so do I need to write reason? The answer is this one is optional. That means that here, even the word given, okay, and this one, they are optional. So surely you can always write reason for any questions about geometry, just like what you learned in Form 1, 2, 3. In Form 4 also, there will be some question you don't need to write so long words reason, for example, this one. Because this one is simply from property of the triangle, so you can just state the fact, okay, from what you have. For example, why do I know CN should always be equal to ND? Because ON is perpendicular to CD, and CD is inside circle. So I know from isosceles triangle that CN should equals to DN by property of the triangle. But you don't need to show the reason, so you can just say, so since ON perpendicular to CD, so you have CN equals to DN in practical. That means that you don't need to write so long reason here. So after that, then you find the length using anything that you have learned. For example, in right angle triangle, usually we may sometimes have to use Pythagoras sphere. Okay, so this one, okay, not always used, but sometimes it may be useful, just like example 1 here. Besides example 1, you can also see some question like example 2, but I just skip here because if we have the chord bisected, for example, AM equals to MB, then I can write right angle for angle OMB. That means that the next step, then I can write this one is right angle. So once you have right angle, then you can do any questions about angle, including those angles of triangle, exterior angle, triangle, and so on. Okay, so you can see that actually you can see that when we talk about the chords, okay, they are not difficult. So even the example 3 also, so this one is also very easy, okay. But this time, if I want to find the chords of the circle, is also easy. Why? Because you know that this time, if I say the perpendicular bisector of a chord AB, then I should know the center should be somewhere else on CD because the property of this triangle. But you know that now, if the center is within CD, it means that the line COD itself should be a diameter. So once you have known the diameter, then I can just simply divide the diameter by 2 to get the radius. So why the answer is 4 cm? Because you just take 8 cm over 2, then you can easily get, okay, the radius is 4 cm. So you can see it's very easy, okay, even you write the reason, it's very easy to understand. So sometimes you have to remember we may have to combine with equations. For example, this time if I want to find R, find the radius of the circle. So if I say R, this time I can write OA is RCM and also, OA is RCM and OB is RCM. But this time, how do we form a formula to get, okay, to get the R? We have to rely on this triangle. And do remember is that to rely on this triangle also, it means that we have to find ON. But you know that ON should be the radius from O towards the P, okay, to subtract the part of MP. But you know that OP is simply the radius, so we can just say OP is R and MP is 7 in meter. So why we can write this one is R minus 7 meter. That means that the last is that now I can work for this triangle to get RCM and then R minus 7, not CM here, sorry, it should not be CM. I'm doing wrong here because I intentionally think that this one should be in the unit of cm, but it should be am only, sorry, so I just clean here. Okay, for example, you have this. Then you should also understand is that now the last part, the horizontal line here should be half of the 38. That means that this one you just simply take the 38 over 2, you get 19. So you can easily say sometimes we have to work on right angle triangle. Okay, we also have to work on the right angle triangle when we solve the problem. So why the book reminds you to use Pythagoras theorem is one of the reasons like this. Okay, so I mean this one is also easy. After you solve, you got it out, then you can get the radius. Okay, now besides of this, okay, we have to understand that in this section there will be also some properties extending the other triangle. For example, the equal chords. So why we have the equal chords? For example, now if I say in the circle, you have 2 chords with the same length. But you have to get the idea what I said before is that when we talk about the circles, okay, you have 2 chords this time. And you can see the 2 chords are equal in length. Then actually there will be something, okay, are hidden inside this circle. For example, once again, I mark the center O of the circle like here. Then you should know that from O joining A, O joining B, even you join to C and D because you have 2 chords, then you would know that these lengths are all the same. It means that after you have drawn the length, then you can see that two triangles, and you can also see that these two triangles are actually the same, or simply we say they are congruent, because you can easily see that, okay, the lengths, okay, are all determined for no matter for the chord and the radius. So you can simply to know that it is the SSS relation to say that now the chords are really equal. So you will have this congruent triangle. So because they are congruent triangle, it means that all the things you have drawn accordingly should be the same. For example, if I have drawn the O from O towards the AB with right angle, and also O join the CD with right angle, then I say this point is called E and F. Then you should also have OE equals to OF, because this one is simply the symmetrical relation by two congruent triangles. That means that once you have drawn a right angle here, so with the length OE, then OF with the right angle also, they should have the equal length. Besides, if I have set AE, okay, and BE will have the equal length with the length with one stroke or two strokes here, then you should understand is that these two should also with two strokes. That means that you will also have AB and CD together are the same, or the parts AE, EB, CF, and DF are the same. So actually, once again, by also triangle with congruent triangle also, so we have some equal chord properties. For example, now you can say equidistant from center. What does it mean? That means that if you have equal chords, then join from O towards the chord perpendicular, then the distance should be the same. So actually, just mentioned before by congruent triangle. And also is that the reverse, the converse. It means that now if I have the distance the same, then the chord should also be the same. So this one is also easy to be derived by using the congruent triangle, because now if we have really such a case, then we can join the OA, OB, OC, OD again. Then once again, you can see there are many okay congruent triangles. For example, in this problem, I can write a triangle OAM, triangle OBM, and then so on. So you can see all the triangles are actually congruent to each other. So because they're congruent, so they should have the equal length. So this one is also very easy to understand if I put it back using the triangles. For example, congruent triangle and also triangle to understand what is going on. Okay, so you can see that, okay, in the examples we will also use those reasons. Once again, you don't need to use so long word. For example, here you can see I'm writing too long word, so equal cos equal distance from center. So remember is that optional again. That means that you don't need to really to write those reasons. Also the word given. Just remember to write what you have, then you write what you want. For example, now you want to show OM equals to M. So what you have CD equals to AB, and CD equals to AB actually is given from the question originally, because we say A boy and CD equals to XCM. So this is what we have. So after we stated what we have, then we can write what we want. We want to find OM, but we want to know ON is OM also. So we write OM equals to ON as a result equals to 3cm. So this is the idea of writing proofs or writing steps to write something like this. Okay. And also like the question 6 also. For the question 6 this time, you can see I have OM equals to ON here. So actually, okay, even I don't see the answer, I can first of all to write a step like this. For example, I can write this time since OM equals to ON, which is given from the question, but you don't need to write the given. Then therefore, I can write the corresponding chord. For example, here OM, the M is on the chord CD, and N is on the chord AB. So I can write CD equals to AB. That means that practically, if you really write for your answer, you write the step just only this. You don't need to write the reason with bracket on the right. Just write this. It is enough for us to do. But actually, it's not finished yet, because after you have shown CD equals to AB, so you may need to what? So you may need to use more reasons to really let us to find what is, okay, the AB or CD or even the PB as the question requires. Okay, as the question requires us to do. But do remember, this one is very easy to do also, because once, okay, because what? So because once you can see that now the scenario is in this way. For example, you have OM is 3cm and ON is 3cm, then you can easily see that I've also gives you that AP is 2 cm, then actually you can find something that help us to get the answer, just like what. So you can see that because I've given you that CD is 10 cm, and also you have the right angle here. That means that now I can write this one as 5 cm, and this part AN is also 5 cm. Okay, by using the property of the triangle again, then you can actually find other things. So I just skip, okay, the concepts to talk here, so you can because always see it from here. And do remember is that besides what I have said before using isotropic triangle, as I mentioned, you may sometimes use 5-axis theorem to solve the problem. But I think that those examples you can easily see how should you do by taking a look at example 7 or even in other examples from the book. The last one, C, circle passing through 3 non-linear points. So this one, I think that I have to tell to you later, because this one is not really related to the calculation of cost of circle. But this concept is quite important for us to learn later, especially when we're considering about the angles in circle. So I tell you this one more detail in the next clip. But this point is just talking about to remind you of very important thing is that what? When we talk about the word non-linear points, it means that this time the 3 points I put should not be drawn as a straight line. That means that the 3 points are not on the same straight line. For example, I can draw the point like this. Then you understand is that okay, because you have 3 points, then I can actually connect these 3 points to form a triangle. And if you also remember that for any triangles, no matter obtuse angle triangle, right angle triangle, acute angle triangle, I can always draw the line which is the perpendicular bisector on each side of the circle. For example, I draw one here, and for example now I may draw the second one here. Okay, so you have the perpendicular bisector intersect at a point, for example here. And you should also remember that what you learn in Form 3 will say that the points, okay, will be shared by the angle the perpendicular bisector speed. That means that all 3 perpendicular bisectors should pass through a point, and we will call this point, if you still remember, it's called the circumcenter. And also you have to understand is that the circumcenter means the center of the circle circumscribed the triangle. It means that now if I highlight this one is green color, then you should expect that the circle should turning round, okay, from this center towards like this. So I cannot draw very good, okay, because I just use my finger to draw. But actually the idea should be something like in this way. So we will call this one the circumcircle around this triangle. And what is the meaning of one and only one? It means that we can only draw one circumcircle for a triangle. It's natural because for every triangle you can only draw one circumcenter by using the perpendicular bisector, as proved in Form 3. So because you have only one center, and the radius should be fixed. Why? Because once you have the center, then you take the center, okay, and any point towards the triangle, for example this one, then we will say this part of the length, which is this one, should be the radius of the circle. Because you have defined only one center and one length of radius, so you have only one circle. So this is the meaning of this. But actually this one may not be very useful for us to solve the problem in 10.2. But just keep in mind because we will use them later. Okay, use it later. So you can see that, okay, before I end this session, okay, I just give you the summary. Do remember is that when we talk about the circle, so we have to remember the two important things is that when we talk about a circle, you should have to define center and radius. And also when we talk about the chords, that means that the straight line segments, okay, inside circle, actually it always relates what we learned in, okay, in Form 2 about isosceles triangle. But why can we relate chords with isosceles triangle? Because besides of chords, we will have a very important thing in circle always, which is the radius of the circle. But usually we will not only talk about one radius, but there will be two radii to say the legs of the isosceles triangle. With the chord, we have the isosceles triangle comes. So we will say the radii and the chords will make you find isosceles triangle. That means that we have to use all the isosceles triangle property to solve the problem. Okay, now I leave some classwork for you to take the practice. Okay, although some of the questions repeats with Mr. Kai gave you, try to do them. Okay, once again to me. Okay, question 11, 13, 15. But there will be also 3 level 2 questions I would like you to try, even you are in 4ABCD. Okay, not 4E. Just say BCD. Okay, you just in Form 4 BCD. Okay, you try to do some level 2 questions because I think that these 3 level 2 questions are not really difficult, and also you have to face them when you sit in DSC. Okay, these 6 questions: 11, 13, 15, 20, 21, 22. So I would like to set the due date of this homework just like Mr. Kai said on Monday. On Monday, okay, on the coming, is it a coming Monday? Yeah, it should be the 22nd. Okay, 22nd of March. Okay, I would like to set the same day as you hand to me. So try to see if you have a problem. Once again, if you have any problem, please feel free to ask me. Okay, so I will always at the back to you, support you. Thank you very much. Stay healthy and keep happily to do all the things. Goodbye and stay tuned.